We're asked to solve the right triangle shown below. Give the lengths to the nearest tenth. So when they say solve the right triangle, we can assume that they're saying, hey, figure out the lengths of all the sides, so whatever A is equal to, whatever B is equal to, and also what are all the angles of the right triangle. They've given two of them. We might have to figure out this third right over here. So there's multiple ways to tackle this, but we'll just try to tackle side XW first, try to figure out what A is. And I'll give you a hint. You can use a calculator, and using a calculator, you can use your trigonometric functions that we've looked at a good bit now. So I'll give you a few seconds to think about how to figure out what A is. Well, what do we know? We know this angle y right over here. We know the side adjacent to angle y. And length A, this is the side, that's the length of the side that is opposite. That is opposite to angle y. So what trigonometric ratio deals with the opposite and the adjacent? So if we're looking at angle y, relative to angle y, this is the opposite, and this right over here is the adjacent. Well, if we don't remember, we can go back to SOHCAHTOA. Sine deals with opposite and hypotenuse. Cosine deals with adjacent and hypotenuse. Tangent deals with opposite over adjacent. Opposite over adjacent. So we can say that the tangent of 65 degrees of that angle of 65 degrees is equal to the opposite, the length of the opposite side, which we know has length A, over the length of the adjacent side, which they gave us in the diagram, which has length 5. And you might say, well, how do I figure out A? Well, we can use our calculator to evaluate what the tangent of 65 degrees are, and then we can solve for A. And actually, if we just want to get the expression explicitly solving for A, we can just multiply both sides of this equation times 5. So let's do that. 5 times 5. These cancel out, and we are left with, if we flip the equal around, we're left with A is equal to 5 times the tangent of 65 degrees. So now we can get our calculator out and figure out what this is to the nearest tenth. Get my handy TI-85 out, and I have 5 times the tangent. No, I didn't need to press that second right over there, just the regular tangent of 65 degrees. And I get, if I round to the nearest tenth, like they asked me to, I get 10.7. So A is approximately equal to 10.7. I say approximately because I rounded it down. This is not the exact number, but A is equal to 10.7. So we now know that this has length 10.7 approximately. There's several ways that we can try to tackle B, and I'll let you pick the way you want to, but then I'll just do it the way I would like to. So my next question to you is, what is the length of the side YW, or what is the value of B? Well, there's several ways to do it. This is the hypotenuse, so we could use trigonometric functions that deal with adjacent over hypotenuse or opposite over hypotenuse. Or we could just use the Pythagorean theorem. We know two sides of a right triangle. We can come up with the third side. I will go with using trigonometric ratios, since that's what we've been working on a good bit. So this length B, that's the length of the hypotenuse. So this side WY is the hypotenuse. And so what trigonometric ratios, and we can decide what we want to use. We could use opposite in hypotenuse. We could use adjacent in hypotenuse. Since we know that xy is exactly 5, and we don't have to deal with this approximation, let's use that side. So what trigonometric ratios deal with adjacent and hypotenuse? Well, we see from SOHCAHTOA, cosine deals with adjacent over hypotenuse. So we could say that the cosine of 65 degrees is equal to the length of the adjacent side, which is 5, over the length of the hypotenuse, which has length B. And then we can try to solve for B. You multiply both sides times B, you're left with B times cosine of 65 degrees is equal to 5. And then to solve for b, you could divide both sides by cosine of 65 degrees. This is just a number here, so we're just dividing. We have to figure it out with our calculator, but this is just going to evaluate to some number. So we can divide both sides by that, by cosine of 65 degrees, cosine of 65 degrees, and we're left with b is equal to 5 over the cosine of 65 degrees. So let us now use our calculator to figure out the length of b. The length of b is 5 divided by cosine of 65 degrees. And I get, if I round to the nearest tenth, 11.8. So b is approximately equal to, rounded to the nearest tenth, 11.8. So b is equal to 11.8. And then we're almost done solving this right triangle. And you could have figured this out using the Pythagorean theorem as well, saying that 5 squared plus 10.7 squared should be equal to b squared, and hopefully you would get the exact same answer. And the last thing we have to figure out is the measure of angle W. Angle W right over here. So I'll give you a few seconds to think about what the measure of angle W is. Well, here we just have to remember that the sum of the angles of a triangle add up to 180 degrees. So angle W plus 65 degrees, that's this angle right up here, plus the right angle, this is a right triangle, they're going to add up to 180 degrees. So all we need to do is, well, we could simplify the left-hand side right over here. 65 plus 90 is 155. So angle W plus 155 degrees is equal to 180 degrees. And then we get angle W, if we subtract 155 from both sides, angle W is equal to 25 degrees. And we are done solving the right triangle shown below.